Welcome to Do the Math America. I am Charlene, Math Shaman. This is Lesson 12, Powers and Exponents. We work out of the beginning algebra book, pages 21 and 22. Please use the link in the description box below this video for the PDF file to print out a hard copy of this textbook for yourself. It is out of print and no longer available for purchase. My video lessons, number 7 through 47, are from the materials of this book. Powers and exponents. In the expression 5 to the third power, 3 is called the exponent, or power of 5. 5 is called the base. 5 to the third power is the exponential or power form of 5 times 5 times 5. The exponent 3 in the expression 5 to the third power means that there are 3 repeated factors of 5. Exponential form or power form, a to the nth power, is a short way to write a multiplication product of n repeated factors of a. So a to the nth power equals a times a times a, however many n repeated factors of a. The expression 5 with an exponent of 1 you read as 5 to the first power. 5 with an exponent of 2 reads as 5 to the second power, or 5 squared. 5 with an exponent of 3 reads as 5 to the third power, or 5 cubed. 5 with an exponent of n reads as 5 to the nth power. Any number can be written as the number to the first power. So 1 equals 1 to the first power. 2 equals 2 to the first power. Negative 3 equals negative 3 to the first power. 4 equals 4 to the first power. Negative 5 equals negative 5 to the first power. 99 equals 99 to the first power. 100 equals 100 to the first power, etc. Write each product using exponents. 2 times 2 equals 2 to the second power, or 2 squared. 2 times 2 times 2 equals 2 to the third power, or 2 cubed. 2 times 2 times 2 times 2 equals 2 to the fourth power. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2 equals negative 2 in parenthesis to the fifth power. 3 times 3 equals 3 to the second power, or 3 squared. 3 times 3 times 3 equals 3 to the third power, or 3 cubed. 7 squared equals 7 to the second power. 7 cubed equals 7 to the third power. The expression 3a squared means that a is squared, but not 3. So 3a squared equals 3 times a times a. The expression open parenthesis 3a close parenthesis square means that 3 and a are both squared. So when you see a parenthesis, you apply the exponent to each character within the parenthesis. In this case, that would be 3a times 3a, which equals 9a squared. Notice that negative 3 squared does not equal negative 3 within parenthesis squared. Negative 3 squared equals negative 3 times positive 3, which equals negative 9. Meanwhile, negative 3 within a parenthesis square equals negative 3 times negative 3, which equals positive 9, because two negative numbers multiplied together equals positive. Negative 2 to the fourth power equals negative 2 times 2 times 2 times 2, which equals negative 16. Negative 2 inside of the parenthesis to the fourth power, however, equals negative 2 times negative 2 times negative 2 times negative 2, which equals 16, positive 16. So negative a within a parenthesis to the nth power is positive if n, or the exponent, is an even number. So negative 1 within parenthesis to the second power equals positive 1. Negative 1 within the parenthesis to the 50th power equals 1. Negative 1 to the within the parenthesis to the 100th power also equals 1. On the other hand, negative a within the parenthesis to the nth power is negative if n, or the exponent, is an odd number. So negative 1 within the parenthesis to the third power is negative 1. Negative 1 inside parenthesis to the 49th power also equals negative 1. Negative 1 inside parenthesis to the 99th power also equals negative 1. Negative 2 inside parenthesis to the 19th power, an odd number, equals negative 2 to the 19th power. Negative 2 inside the parenthesis to the 20th power, however, is a positive 2 to the 20th power because exponent 20 is an even number. General rules of exponents, powers. If a is any non-zero real number, then number 1, a to the m times a to the nth power equals a to the m plus n power. Rule number 2, a to the m power divided by a to the nth power equals a to the m minus n power. And rule number 3, a to the 0 power equals 1 if a does not equal 0. So we have 3 rules. 1, a to the m times a to the n equals a to the m plus n. 2, a to the m divided by a to the nth power equals a to the m minus n. And 3, a to the 0 power equals 1 if a does not equal 0. So that means 1 to the 0 power equals 1, 2 to the 0 power equals 1, 3 to the 0 power equals 1, 100 to the 0 power equals 1, etc. 0 to the 0 power, however, is undefined. It means that the power of 0 does not apply to 0 itself. Let's look at some examples. 2 to the 30th power times 2 to the 10th power equals 2 to the 30 plus 10, which equals 2 to the 40th power. 2 to the 30th power divided by 2 to the 10th power equals 2 to the 30 minus 10th power, which equals 2 to the 20th power. 2 to the 10th power divided by 2 to the 10th power equals 1, because any number divided by itself equals 1. The other way to think of this is 2 to the 10th power divided by 2 to the 10th power equals 2 to the 10 minus 10th power, which equals 0. 10 minus 10 equals 0. So you have 2 to the 0 power, which also equals 1. The practice problems for this lesson can be found on page 22. Please do as many problems as you need to get a firm grasp of this material, and please check your answers with those in the back of the book to make sure you did the problems correctly. Those solutions are on page 290. I hope this video was helpful for you. Thank you for joining me at Do the Math America.